Today we're going to pick up and continue with function notation and also work more with those evaluating of functions, which is similar to that problem K that we had on our POD 414. This first part, I don't want you to write this first part down with this function machine. I just want you to take a look at it and follow with me to get an idea and recall exactly what you do when we're dealing with functions and how they operate. So we have here your independent variable, which is that domain. It's that x value that you are putting in to the function. So for example, we have these nut values here, which are 2, 3, 4, 5, and 6. We put them in, and then inside here we have our function. And so in our case here, f of x, or our function, is x plus 4. So if we put these values in, so for example, if we take 2 and put it in there, that means we're putting 2 in for x, and if we take 2 plus 4, the value we get out is our 6. So then we write, which is a part of our range, it's our dependent value because what we get out depends upon what we put in. And then we have our function notation that we write in the form of an ordered pair, with the first value being your x-coordinate, which in our case for that first one is 2. And then our second value is that f of x, that function that we get out, which in our case when we did use the function of x plus 4, we got out 6. So our function notation would be 2, 6. Now, specifically speaking, when we talk about function notation is when the set of ordered pairs described by an equation satisfies the definition of a function. Now, I know that seems like a lot of writing to do. One of the things you want to learn while you're here in high school is how to abbreviate. So work on abbreviating and creating some shorthand that you can still go back and understand when you read it to study. So if we look here at this example down here, f of x is our output value. That's what defines that it is a function. And our input value is going to be that x into the function 5x plus 3. So f of x equals 5 times x plus 3 would be how you would read it. So if we put in 1 for x, which would be f of 1, we'd take 5 times 1 plus 3 to get our value of 8, which would then give me a ordered pair for function notation of 1, 8. Now, let's go ahead and take a look at some examples here on how you write function notation and evaluate this function. So we are given here this function of y, given y equals 3x plus 6. If we want to actually write that in a better function notation, we would say f of x equals 3x plus 6. So what we want to do is we want to find these values here. And when we say f of 0, we're simply saying where that x is in that function, put in a 0. So in this case, we would have 3 times 0 plus 6, which if we evaluate that using our order of operations from 1, 4, we get 6. F of 1, same thing. 3 times 1 plus 6. 3 times 1 is 3, plus 6 is 9. F of 2, we have 3 times 2 plus 6. 3 times 2 is 6, plus 6 is 12. Now we have one a little bit trickier. We have f of x plus 2. So we take 3 and we replace it with x plus 2 plus 6. So as we recall, we need to distribute here. So we have 3 times x, which is 3x. 3 times 2, which is 6, plus 6, which is 12. And finally, we want to evaluate f of t, which simply means we're going to put in t in place of x. So if you think about that, that really simply changes the x to a t to give us 3t plus 6. So what I want you to do now, take some time, push pause on the video, and I want you to fill in B, and then when you are done, press play and check your work. All right, let's start off, see if you did it correctly. We have f of x is going to be equal to 3x squared plus x. And so we're first going to look at f of 2. So we have 3 times 2 squared plus 2. 2 squared is 4. 4 times 3 is 12. Plus 2 is 14. Then we have f of negative 2. So we have 3 times negative 2 squared plus negative 2. Negative 2 squared is positive 4. Positive 4 times 3 is positive 12. Plus negative 2 is 10.